sure that the flow lines keep working, Ford abolished local efficiencies. He never measured local efficiencies of stations. All that he measured was what was stopping the flow, what was reducing the rate at which the product moved through the system. If it was quality problem, quality was analyzed. If it was inventory shortage, inventory systems were put into place, which led to the development of MRP, the materials requirement planning part of it, which often told people that when the material should be ordered so that the material shortages don't take place. All this was aimed at single-mindedly increasing the flow. So in terms of increasing the flow or increasing local efficiencies, Ford chose flow. This was the same concept that Taiichi Ohno got a grip on and adopted it to Toyota production system. But Toyota's work environment was very different. Where Henry Ford says he would make millions of cars, sell them across America, Toyota did not have that luxury. The brilliance of Taiichi Ohno comes out when you see how he beautifully used the concept of flow but adopted it to his environment. The concepts of flow are simple, that you have to make sure that the rate at which the material flows through the system is constantly increasing. Any variation in output is a deterrence. However, you should also know when not to produce. That means for the flow to remain balanced and flow equally through the system or at the same speed throughout the system, you have also to know when to stop overproduction. Ford used the space as his control mechanism to stop overproduction. Because if there's no space, where would the manufacturing station produce and leave the inventory? Increase flow, make sure there's a practical mechanism to control overproduction. And another very important part was that abolish local efficiencies. These were the concepts of flow which Henry Ford developed. And they were so powerful that they have been used not only in, let us say, car manufacturing, but Coca-Cola uses it, bottling plants, ammunition plants, food industry, milk processing, everywhere there are flow lines being used. And these flow lines have only one thing, that if we have to increase the rate of flow of material, what do we do? And this is what has driven this industry to high levels of automation. Bottling plants. What do? Nothing. You just take one bottle and check the content and that's it. Bread making. Everything is all assembly line. The reason why assembly line works is because actually it is a true efficient process and you can do a lot with very less. Henry Ford gave us the concept of flow, which lead to very efficient and profitable organizations. In fact, he was so well focused that he achieved the highest throughput per labor of his plant in an automobile industry ever. If one starts looking at Ford's behavior from flow point of view, all his behaviors are very nicely explained. He gave Taylor the job of scientific analysis of work. But he never says divide the work. He says, please make sure that only the productive part of the labor is online, rest is offline. Anything which interferes with flow, you take it offline. And so the division of labor, as is normally known, was born. But the prime thing was to make sure that only productive thing which increases the flow of material or product through the system is focused on, is called productive. Rest is not. Many say Ford was a very controlling person. He wanted to know exactly everything and how it can be done. And so he went in for standardization. That means there would be very less variation. But once you start looking at what Ford was trying to achieve, a setup change was a disruption to flow. Whether it was in his shop assembling a car or a component manufacturing unit. So if you do a setup and produce millions of products on the same setup, what did you do? You actually increase the flow. You didn't save cost. Or it was not the least cost production. So in Henry Ford's time, flow was such an important thing, and anything that came in between flow was very systematically and scientifically removed or abolished. Model improvements were primarily done, the processes were properly laid out to make sure that the flow happens. Local efficiencies were abolished because they were interfering with flow. So this is the genius of the great thinker Henry Ford, who introduced to the world concept of flow. And this concept is what we see being beautifully adopted by Toyota to such a beautiful level that it has given itself a new application, and that application of flow concept in the environment of Toyota is now known as Toyota Production System. What is the beauty of Toyota Production System and why was it a challenge? We will see next. Flow concepts, as demonstrated by Ford, were proven and the manufacturing practices were so widely used that everything was perfect. However, when you want to apply the flow concept to an environment like Toyota, where individual equipments could not be dedicated to the volumes they had to produce, it was a big challenge. Let's take example of the final assembly station where Taiichi Ohno was first given a charge of. If he had to limit the production by using the same tool as space which Henry Ford was using, the non-availability of a particular material would allow so much of material to be piled up that it would cause a log jam. So Henry Ford knew that he has to do something different, because there were so many models being produced at the final assembly. The absence of even one component for one particular car would make huge amount of material to pile up. And if there was no space to pile up, naturally the output would suffer. Henry Ford had removed this problem by just manufacturing one model. But the demand of product for Toyota was much different, and he had to produce a variety of cars, and these variety of cars had to be produced from the same available machinery. And if these machineries were forced to do a setup change, then by nature the assembly would be falling short of certain components. In fact, the biggest learning Taiichi Ohno got for his system was when he looked at the supermarket. And he says he went to the supermarket, he never saw that the aisles were clogged with a lot of material lying everywhere. When people came, they pulled up what they wanted from the shelves and the material got replenished from the store behind. This is where he got the idea that whatever the person wants to produce, he should be able to pull out or pull up from the inventory, and then the upstream operation would produce what the downstream operation has consumed. And so the idea of Kanban was born. But there's another very interesting thing which Taiichi Ohno keeps reminding most of us today is, how did the stores come up? He kept telling his people that you produce something which I don't want and you leave it on my assembly line. And when the space is used up, you take it somewhere else and store it. And you still keep producing at your wish and free will whatever you want to produce or whatever you can produce, and keep piling it in the store. After the quantity in the stores become very high, you appoint a person to manage that quantity. And when the person cannot manage the quantity, you give him a software to manage the store. So what have you done? You have actually increased the cost of operation of a company. Though the store operations are efficient, but they are not desired. So you have increased the cost of operation of a company by not producing what I want. And one of the reasons for you not to do that was you thought that if your machine kept producing large volumes of one component, the efficiency of the machine was very high. And all this adds up. In fact, Taiichi Ohno faced a Herculean task on increasing the labor efficiency also, or the productivity of the Japanese production system. The first thing he learned was, because of the non-availability of material at the assembly line, most of the work got done in last 10 days of the month. So he says, if I am able to distribute the load evenly, I can do 3 times the work with the current manpower. And this was one of his learning, that if we are targeting to improve productivity by 300% is nothing. You have to target to improve the productivity 10 times. And to do that, that means to level the production. Okay, you had to begin from the assembly line, where everything merges. And whatever the assembly line needs will be supplied to it, and whatever needs to be supplied to the assembly line will be produced by the subsequent lines, and hence on so forth. This might be also termed as the pull system, because whatever has been pulled by the consuming station downstream gets manufactured by upstream. Now it sounds very simple, but this is how Taiichi Ohno surmounted the first hurdle in trying to make sure that the flow happens. So what he did was, he made sure there was no place, but you only produce what was needed downstream. So Kanban was what he invented to make sure that the communication goes to the upstream manufacturing station, that what he has to produce for downstream. So now what you are doing is, you are not allowing overproduction of components which are not needed. So if you limit overproduction, naturally you are using your machines to make sure that only needed components get produced, and when components get produced, the assembly keeps happening, the flow happens. To get the flow on the assembly line moving, you have to only make what is required to be produced. That means please do not produce anything which is not required, or to avoid overproduction. The assumption is that if you can overproduce, that means you have surplus capacity, right? So if you are not using your full capacity to produce, what is the one thing that we are violating? We are violating the efficiency norms of industry. You can make more, but you are not making. And if you are not making more, you are making it at high cost. By just introducing Kanban, Taiichi Ohno had to fight against the conventional norm of high volume production or higher volume production and higher efficiency.